All right, let's take a look at some recursive linear examples. The first one, the number of houses in a town has been growing according to the recursive rule. Now we're looking at this recursive rule, and we look at the formulas that we have. We do have one that looks like P sub n equals P sub n minus 1 plus D. This is linear. And right away, we can see that the plus 148 plus D, we have D for this problem. This is nice. D is 148. We're also given P sub 0 is 213. So that's enough for us to create the explicit model as well. But let's work with the recursive linear model first. P sub 1. Now to find P sub 1, basically what we need to do is we need to plug in 1 for the n. And when we do that, we get P sub 1 equals P sub 1 minus 1. Now 1 minus 1 is 0. So this is P sub 1 equals P sub 0 plus 148. Well, this is great because we have P sub 0. It's 213 plus 148. And we add those together. Let's not take any chances. $361. That is P sub 1. Now we also want to calculate P sub 2. Now to work out P sub 2, we need to plug in a 2 into the formula. When we plug in a 2 into the formula, the right side will get a 2 minus 1 subscript, and 2 minus 1 is 1. So we get P sub 2 equals P sub 1, again plus 148. This is good because we just got P sub 1. P sub 1 is 361 plus 148. That would be 509, but let's not take any chances. 361, it's already in there, so plus 148, 509. So that is answering the first two questions, and what we have done is we've used the recursive model that was provided, the recursive rule, to work out these P sub 1 and P sub 2 populations. Now for part B, an explicit formula, just a reminder, P sub n equals P sub 0 plus dn. This is our explicit model for linear. So we could have P sub n equals, we have P sub 0, it's 213, plus d we have is 148, and then n. Very simple to write the explicit model once you know P sub 0 and d. And one thing we can do with this is check the work that we just did. So if I plug in 1 into this formula, I get 213 plus 148 times 1. That checks our 361. And if I plug in 2 into the formula instead of 1, we should get 509 if we did it right. Perfect, 509. So you can use the explicit model to check your recursive work. For part C, we want to find how many number of houses in 10 years. Now in this problem, it actually doesn't tell us the n is for the number of years. So we're going to have to assume here. Let's assume n is the number of years. So then we're looking for P sub 10. It's the most obvious assumption. Is it correct? Well, we could argue that we need more information, or we can assume. So 213 plus 148 times 10, 1693. and that would be for units, houses. Finally, when will the number of houses reach 1,150? So this 1,150 is not p sub 0, it's not n, it's p sub n. So we plug in the 1,150 in for p sub n, you get the equation 1,150 equals 213 plus 148n. And now we just go through and solve for n, doing our adds and subtracts first. And 1,150 minus 213, 937. And then divide by 148. Here we're going to likely run into decimals, so let's check the nearest tenth of a year. Dividing by 148, round to the nearest tenth, 6.3. Approximately 6.3 years later. Okay, now it's your turn. Go ahead and pause the video and work on the questions on the right and see what you get. Okay, we should be getting p sub 1 equals 7,440 and p sub 2 equals 7,530. Explicit formula, p sub n equals 7,350 plus 90n. For part C, p sub 10 equals 8,250. And for part D, n is approximately 42.2 years. The last thing I wanted to do is to show you that you can get these recursive examples done with a calculator in a different approach. So as an example, on this problem on the right, you start off by entering p sub 0. So I need to raise this up a little bit so it's all recorded close. All right, so that would be 7,350. Enter. Now when you have a recursive rule, p sub n equals p sub n minus 1 plus 90. Anywhere you see a p sub n minus 1, you use the answer button. So that second answer, and then plus 90. So this recursive rule on the right is answer plus 90. And what the calculator is going to do is plug in the 7,350 in for the answer, then add 90, and we should get p sub 1. Enter, p sub 1. Because I coded it with answer, if I hit enter again, it'll do the recursive rule again, and we'll get p sub 2. P sub 3, 4, 5, 6, 7, 8, 9. Here's p sub 10. This way we can verify all of this work. And we want to get to 11,150 in 42.2 years. We can't go to the nearest tenth with this, but that's 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 4, 5, 6, 7, 8, 9, 30, 1, 2, 3, 4, 5, 6, 7, 8, 9, 40. There's 40, 41, 42. It's a little after 42, but it's before 43. So we can't get to the nearest tenth, but at least we can get to, yeah, I'm pretty sure 42.2 is the right answer. Although I couldn't get it with this method, I verified that it's a little after 42 and it's before 43, and that makes me feel much better about that answer. All right, I hope this all helps.